Today we will deal the vertical members and diagonal members for the same problem. Okay, so 4 into 6, 24 meters. Height is also 4 meters. Okay, so we gave designations like L1, L2, L3, L4, L5, L6, L7, U2, U3, U6. Okay, today we will deal vertical members. Vertical members. Just avoid U2, L2. Sir, why is sir avoided? Just see it is U2, L2. This is U2, L2 na? Just observe it. It is a U2, L2 member. These two members are joining. L2 is there. When the load is at that position only, it will get value. Remaining positions, U2, L2 is 0 because three members are joining at the joint. Two members are in same direction. One member is in any direction. It will be 0. You already know is TRUSS. So the remaining two members L1, L2, L2, L3 joining in the same direction. So any force, they will balance it. Remaining any member, any direction is 0. We already know is because these two exactly equal. The other member force, who will take it? Who will take care? Who will take care? Nothing. No one will take care. That's why it is 0. So that for purpose you just avoid it. Okay, avoid it. So not only that, U2, L2, U4, L4 also same situation. U4, L4 also same situation. Okay, so that's why we don't need to calculate influence line diagram. You can easily saying it. Like you can easily saying it. Okay, you can easily directly you can write down. That's exactly 1 when the load is exactly applied at L1. Remaining time is 0, but see, we calculated like this for when the load is applied at joints only. If you take care of the loads only at joints, if you load it applied at L2 joint, it will reach 1. Remaining joints, it's 0, completely 0. It's 0, 0, 0, everything is 0. But in between these, sir, so in reality we don't calculate those permissions, but if you applied a load in between like this, it will take a small portions. So that's why we just feel that it's a, so everything is 0, 0, 0, 0. In reality we will apply the loads at only joints. In between joints we don't take it is. Okay, so that's why just influences, just write down influences. In between it will reach, it's a 1, it's a 0, it's 0. Remaining everything is 0. So this is for U2, L2. So this is not same. U4, L4 also. U4, L4 also same thing. Exactly when load is applied at L4 only, it will take 1. L1, L2, L3, L4, L4. It's 1. So remaining every joints is 0, but in between U3 to U5 or L3 to L5, it will get small influence. We will write only influence. Remaining everything is 0 because so the position of L4, U4 like that. The two members are joining in the same direction. only extra force is there, it won't take care anything. So that is not a case. That is not a big deal. So we will deal with U3L3. Okay, we'll take care of U3L3. That is the situation. So U3L3, take it. Sir, how we will do? How we will deal with the U3L3? How you will deal with? So to find out the vertical force, na? Vertical force. Sir, how we will cut it? So see, same thing at L1, at L7 the load is there, directly reaction will take place, reaction will develop, no truss member take care anything. So, okay, remaining positions. So load is at L2, load is at L2. So what is the value, what is the force it taken by U3L3? How we will do, sir? Same thing, okay, same thing, no problem at all, just cut the sections. How we will deal, how we will do this, sir? How we will deal? You have to cut like this. So how can you cut it? You have to cut like this. You have to cut it like this, because we want U3L3, na? We want U3L3. Cut it, so just cut it and see it reaction is there. So what is that reaction? So if the load is at L2, it's exactly, it's 20 by 24, it's 4 by 24. We already know it. If you cut it, so the left side has two forces, so no need to avoid it. So we will deal with only left side. So write down the left side part. So left hand part, how it is like this, how it is exactly left side, how is it exactly left side? Left side part, 1 2, that's it. Left side part only have to take care. Only left side, okay. That's it, that's it, na? That's it. That's it. The giant is there like this, okay. So what is this value? This value is, sir, this value is 4 by 24. Very simple, see it is, that is the value of 24 by 24. That's it, na? These are the unbalanced forces. Now you can see this is L3 U3, this is U2 U3. What is this? This value is L3 L4. Very simple, just see. So balance it. Sir, we want to take a moment, no required of moment. I said every cutting portion, or every, if you cut it everywhere, it will be reproduced its equilibrium, then only it's called a total equilibrium. So how do you, sir? We'll just see it is, what will happen? Just see, vertical forces just balance it, just vertical forces balance it exactly. L3 U3 equal to 4 by 24. Vertical forces, no need of U2 E3 L3 L4 is the what horizontal forces, no need at all, directly you can get it exactly same direction, same direction. That is means it's a tension force, it's a tension force, tension force, na? Exactly, you got it, na? Exactly, you got it, it's a tension force. So what is that value? That value is 1 by 6. That value is 1 by 6. 1 by 6. So value 1 by 6. Exactly at L2 portion. Say at L2 1 by 6. That's it. So next check it is. Next check it is at load, it's L3. Load is at L3. Same. Diagram is same, na? Diagram is same. So diagram is same. What is L2? Load at L3. Diagram is same again. Again the same. What is this value? This value is now 8 by 24. Understood? Now if load is L3, it is 8 by 24. So what is that value? So what is exactly L3 U3? Same, 1 by 3. So 8 by 3, 1 by 3. Tension. It is very simple, 1 by 3 tension. So how it is varying? It is varying with respect to the V2 or VB. How the VB is increasing? How the VB is increasing? That's the varying. Up to from L1 position to L3 position, the L3 U3 value is increasing with respect, not with respect to, as it is with respect with as V2 or VB. That is, if you call it as V2 or VB, as it is same. So the L3 U3 portion, L3 U3 value is increasing when the load is from L1 to L3, as it is as the reaction at another support, the reaction at VB. That's it. That's it, na? That's it. That's it. One thing. I said so many times, when the load is maybe altered when L3 and L4, because the section is cut like this, you will check only L3, L4. That's enough. But I will give clarification. That's why I will start with L1, L2, L3, L4. Okay. So now if load is at L4, now load is at L4. Section is same. No need to another way cut. So we will take care of right side. Now we will take care of right side because, see, now we will take care of left side because right side has two forces. Exactly what is this length? We don't know. We cut like this. So that's why. Okay. So take care of right side. So how it is the system? So no load at L4. So how is the system? How the system looks like? Cut it. Exactly, it will come like this. That's it. It exactly looks like this is U2 L2, U2 L2 only, U2 U3. Sorry, U2 U3. This is U2 L2, U2 L2. Sorry, U3 L3. Okay, U3 L3. Okay, this is L1, L2, L3. This is L3 L4. So reaction is it? Exactly what is this reaction? So this reaction is what? If it is L4, what is the reaction? So off. It's off exactly means it's a 12 by 24. 12 by 24. Off, na? It's a 12 by 24. That's it. So this is 12 by 24. So what is U3 for? U3 L3? Just take care of vertical reaction. That's it. Just check it is U3 L3 is what? It's a minus 12 by 24. Because both are in same direction. So compulsory you have to maintain equilibrium. U3 L3 is opposite. So this means it's minus 1 by 2. So it enters a compression. It's enters a compression. So that's the problem. See, up to the load at L3, U3 L3 gets a tension force. When the load enters from L4, when the load is at L4, it is a compression. That means in between to L3 to L4, the load changes from compression to tension to compression. Remaining everything, if the load is at L5, same. It is, what is this value? This value is 8 by 24. So see now you can observe it. The load is at L4 to L7. Exactly the force in the U3 L3 is equal to the VA. So just observe it. From the load is from L1 to L3, the force in the U3 L3 is equal to the VB. But the same thing from the load is it from L4 to L7, The load in the L3 U3 is equal to the VA, and also it turns from tension to the compression. That's it. That's it. So no need to find out the influence lines for this. Just you already know the influence lines for VA and VB. VA VB we do already know it, because VA VB is what? This is the influence. VA VB is how it is changing. VB is changing how? This is one, this is one. You already know it. So up to L1 to L3, the load is, we have to write down the influence line for V2. So that's it. See, now you can observe easily the influence line for L3 U3 is, L3 U3 is up L1, take care, L2, L3, L4, L5, L6, you will feel L7. Up to L1 to L3, the load in the U3 L3 is equal to the influence lines for VB. VB is how? VB is how? VB is how? VB is how? This, like it is increasing. Now VB. So it will goes like this. Up to exactly at L3. What is the load? What is the load? Exactly at load is at, it is a 1 by 6. It is a 1 by 3. It is a 1 by 6. It is a 1 by 3. No need to this also. No need to find out from this also. You can directly say. So what is L VB? VB influence line. Na? You already check it is exactly if it is 24. If it is exactly it's 24 now 124. So what is exactly at 4? For 24 1, for 4 is 4 by 24 1 by 6. 1 by 6. Got it na? This is 1 by 6. We already know it. By the derivation you will get 1 by 6. No need to derivation also. Just from L1 to L3 it's a VB. VB already know. VB is very simple. It's 1. 24 it's 1 increasing. For 4 length it's, for 8 length. For 8 length 8 by 24. 1 by 3. 1 by 3. The same value we got it. 1 by 3. That's it. From L4 to L5. From L4 to L7 it is equal to VA. It is equal to VA. What is VA? VA is, it's a 0 to increase. That's it now. That means what? That means it is exactly, it's a V, it's a 1. It exactly represents VB. Up to this is exactly it's a VA. Exactly it's a VA. It's a VA. It's a 1. You know values. In between any place you can easily find out. So that is the idea. Got the idea? Sir, in between, see, I already said up to L1 to L3 it's a tension force. Tension you can take as a positive, otherwise you can write down tension. So this is compression. In between it is changing from tension to compression, so no need at all. Just join these two lines. In between that's shifting from tension to compression. That's it. It's over. It's over. It's over. Got the idea? So based on that L3 U3, based on L3 U3, U4 L4 is, I already write down. U4 L4 you already write down. U4 L4 already write down. So you can find out U3 L5. U3 L5. Easier because it's exactly replica of U3 L3. Replica, but opposite. Are understood? Exactly opposite. So U5 L5 exactly opposite. Just check it is. U5. So are understood? L5 U5 exactly opposite. Exactly opposite. How will get? Exactly opposite. L5. So you can write down. This is L7, L6, L5, L4, L3, L2, L1. Exactly opposite. Exactly opposite. See. So you can maintain like this only. Otherwise, no need at all. See. You can write it. For U3 L3 exactly L3 to L4. So U5 L5 L5 to L4. That's it, na? L5 to L4. The change is between L5 to L4. L5 to L4. L5 to L4. So maintain it. L4 L5. The change is between these two values. So okay. So exactly, but exactly opposite. This is negative. This is positive. Replica, na? Replica outside. Otherwise you can calculate it. Otherwise you can calculate it here. No problem. Just exactly opposite. Just add it. Just add it. So sorry, I will add with white color. So what is this value? This value is 2 by 6. This value is, sorry, this value is what? This is value 1 by 3. This value is what? We got it. This value is 1 by 2. We got it. So this is, we got it. This is exactly, it's 1 by 3. It is exactly, it's 2 by 1 by 2. Off now, L by 4. It's exactly, it's off. It's exactly off means what? You will get off. It is only 1/3. It will get 1/3. It's 1/3. It's 1 2. 1/3 and 1 2. So exactly L4 and L5. Shifting from L4 to L5. Same VA VB. No other things are required. No other things are required. So L3 U3 you got it. L5 U5 you got it. So U2 L2 we already write down. U4 L4 we already write down. So compare with U6 L6 also same thing. It is also same thing. This L5 L6 L6 L7 it's the same direction. So U6 L6 is another direction. So you will same thing. Same. This is the replica. This is a replica. This is a replica. That's replica. So these three things are collide like this. If it is the shape is this. Okay. So remaining these two we got it. Only VA and VB sufficient. We developed here like this. Based on that you can directly copy it. Otherwise someone ask only for particular member, you can easily find out it. So only take care of the left hand. If you cut the section, so one thing L3 and L4. If you cut the section for L5 L6, how can you cut it? You will cut like this. You will cut like this. You can take care of L5 and L4. You will do it at any section. Just do it and you got the same thing. That's it. Now? That's it for vertical members. Now we will go to the diagonal members. Now we will go to the diagonal members. Diagonal members. I will write down the diagram again because every time go to up and down it's too hectic. Okay. 4 into 6 it's a 24. Height is also 4. Okay. So designations L1, L2, L3, L4, L4, L6, L7, U2, U3, U4, U5, U6. Okay. Now we will take a diagonal member. For L1, U2, just avoid it. It's outside. Just avoid it. We will take care of U2, L3. First, we will take care of U2, L3. Okay. U2, L3. Diagonal member. U3, L3. Okay. So we will first see U3, U2, L3. U2, L3. Okay. Just check it is U2 L3. So load is at L1 is everything is 0, no need at all. So load is at L2. Load is at L2. We have to find out the U2 L3. Sir, how? So same thing, cut it. Cut it like this. Cut it like this. Cut it like this, and you can just avoid the left portion. Just take care of right portion, because the left portion has two forces are there, and we don't know this distance. We don't know that distance. We just cut it in somewhere. Okay, so just take care of the right section. It's okay. Right section. Just how it is. How it is look like. This one, this one, and this one. That's it. That's it. Three things are there. What is this? The 4 here. Force is here. This force is 4 by 24. This force is 20 by 24. That's it. 4 by 24. It's 10 by 24. So this is U2 U3. This is U2 L3. This is L2 L3. So this is 4 by 24. So we want U2 L3. Sir, how can you find out? Easily find out, yeah. Easily find out. So how can you find out, sir? So you can find out by balancing the forces itself. Sir, this is a vertical force, this is an inclined force. How can balance, sir? By balancing the vertical component of this force, because these two forces are horizontal forces. Horizontal forces, no need to do. So what is the horizontal equilibrium? No need. Just avoid it and we'll get vertical equilibrium. So take care of this is a theta. What is theta? So what is the vertical equilibrium? Vertical equilibrium. So U2 E3 cos that is nice sine theta. If it is taken, this is the theta. What is sine theta? Sine theta will get 4 by 24. So same direction is equal to 0. That's it. U2 U3 sine theta will give vertical component plus 4 by 24 is equal to 0. That's it. So what is U2 U3? Minus 4 by 24 cosec theta. That's it. That's it. So what is the cosec theta? So what is cosec theta? This is theta, na? So what is cosec theta? 1 by sin theta. What is sin theta? What is sin theta? So this is a 4. This is a 4. 4 by 4. This is 4 root 2. That is 4 root 2, na? 4 by 4 root 2. You will get 1 by root 2. That is sin theta. Cosec theta? Root 2. So cosec theta is root 2. Root 2. 4 by 24 root 2. So just avoid cosec theta. What is this? This is equal to VB. So VB cosec theta. That's it, na? VB cosec theta. Most probably the elements in the trusses are arranged exactly some manner. Don't change those thetas for every segment. They don't change it. They give equal spaces and they will provide equal thetas, most probably. So for every segment theta is changing, sir. So if changing, you can calculate it. But most probably no need. Okay. So that's it. If you just observe it, it's a VB cosec theta. If the load is at somewhere here also, so if it is something like this, so it is a VB cosec theta. Okay. So now if you just observe it, now the load is at L3. Now load is at L3. The same section, cut it, but now we will take care of left section. Okay, so just avoid it. Load at L3. It's a load at L2. Write down the cut it. That's it, na? That's it. So this is VA, or otherwise what is the value? What is the value at L3? It's a it's a 16 by 24. That's it, na? It's a 16 by 24. So what is this value? This value is u2 u3. This value is l2 na l2 l3. This is u2 l3. u2 l3. That's it. So just balance the forces. So take care of this is theta. So everything, this is theta. This is also same theta. Understood? We consider this is theta because this is also same. Same na? Exactly same. Both are same. Any vertical line, it's a theta. It's a theta also. Same. So both are same. Both are same. So consider it. Consider it. Vertical equilibrium. U2, U3, U2, U3, sin theta, sin theta. So exactly is equal to the 16 by 24 because both are in opposite direction. So okay. So what is U2, U3? So 16 by 24 cosec theta. Cosec theta. Cosec theta is root 2. Now it is 16 by 23 is what? It is VA. It is VA. And also previously it is a compression. Negative you got. Now it's a tension. Now it is a tension. So just observe it. What is observe it? What you observe it? The load is up to L2. The load is up to L2. The load of U2 E3 is VB cosec theta. The same thing previously what is that? The load in the vertical members up to that point, up to certain point, VB exactly equal to VB. Now its diagonal member is VB cosec theta. That's a small change. VB cosec theta. So understood? So up to this it is a tension. Previously up to that it is a tension. Now it is a compression. Now it is a compression. See? Now it is a compression. Small changes will happen. No need to remember because no one asked this what is the compression member. No one asked. This is changes you have to just made it, and if you feel that you can draw influence line diagram that will help to find out the forces in the members. No one remembered, but just observations. So same thing, no change at all. The diagonal members also, it's a change with respect to VB multiply with cosec theta. It's a compression. Now it's the, if the load is changing from the diagonal member from one position to the other position, so U2, U3, for U2 position or same L2 position, L2 position up to L2 position, it's a compression. For L3 position, it's a tension. But the changes is with respect to the VB only, VB and VA. So no need to try. No, so directly you can draw influence line diagram. How can sir? ILD for U2, L3. So just do it. Just it's L1, L2, L3, L4, L5, L6, L7 up to L2. Up to L2, it's a changing with respect to VB. So how is VB? VB is moving. That's na up to L2 na. So okay, up to L2 because up to L2. Up to L2 is changing with respect to VB. So cosec theta just avoid it. Just avoid, I will say it. So later from L3 onwards, it's changing with respect to VA. So VA is how is moving. VA is how is moving. VA is how is moving. That's it. Huh? That's it. That's it. You can just, otherwise you can just extend it. You will get, it's a 1. So extend it. You will get it's 1. That's it. Na? That's it. Up to this V2, it's a compression. It's a tension. In between it is changes. In between is changes from compression to tension. That's it. But the values are the high value. So you can easily find out. Sir, you can easily find out. It's, what is this value? It's a 24. It's 1 total 24. For 24 it's 1. For 4 1 by 6. This is 1 by 6. This is what? This is 1 2 3 4 4 segments 16. For 24 it's 1 16 16 by 24. 4 4 ja 4 6 ja 2 by 3. It's a 2 by 3. So not that value exactly. It's a value of See, it's a, what is this value? 16 by 24. 4 4 ja 4 6 ja. It's a 2 by 3. 2 by 3 na? It's a value of 1 by 6. We already know it. Sir, multiply with cosec theta. That's it. That's it. Now you can observe, note observe, multiply with cosec theta. Multiply with cosec theta. And it's a 1. It's a 1, not 1. It's a 1 multiply with cosec theta. You can write down directly it's a cosec theta. Just multiplication. Na? So it's not a 1. It's a cosec theta. Cosec theta value is now it's a root 2. It's a root 2. It's a root 2 na cosec theta value. So that's it. Changes from 0 to root 2 constantly. But no need to draw with respect to root 2. You can draw with respect to 1 and multiply with every point is multiply with root 2. That's enough. Every segment, every influence, you can multiply with root 2. That's it. So that's just, this is a 1. We multiply with every value with respect to root 2. How it's shifted? It's shifted like this. That's it. It's a root 2. So by representation, you can just draw with respect to 1 and just show it is multiply with root 2. So it is 2 by root 3, it's root 2. 1 by 6 root 2. That's it. That's it. Okay. Now you can easily say, you can easily write down for the influence line for U3 L3. Can you draw? U3 influence line for U3 L4. U3 L4, you can cut it. U3 L4, you can cut it. And up to L3, it's represents of VB. From L4, it's represents of VA. It's represent of VA. So just directly write down. So you can see it's the influence line for U3 L4. What is like? What does it look like? L1, 2, 3, 4, 5, 6. You can take a 7. Up to L3 is VB. Later L4. So, okay. So this is value is what? L4 na? It's off. Its value is for 8. For 8 na? So 24 it's 1, 8, 1 by 3. It's a 1 by 3. So no needed, just join those three. Just join those two. This is compression, this is tension. Join those two and multiply with root 2. Multiply with root 2. Sir, what is root 2? So no need to put root 2 because this is the problem of root 2. So otherwise you can write down 1 root 2 cosec theta. It's a cosec theta. That's it. That is the influence line. That is the influence line. So can you write down the exact replica of other giants? So now you can see. Now you can write down. So U3 L4 you write down. So just did it. So U5 L4. For U5 L4, say exactly opposite of U3 L4. U3 L4 exact opposite na? Exact opposite of U3 L4. U5 L4. Now it is U5 L4. So see, up to this is up to this. So how can you write down? How can you write down? So U2, U3, U4 is just avoided. U5. Okay. U5, L4. You can develop it. Otherwise, you can, if you know one diagonal, say exactly replica. Opposite. Exactly opposite. See how can it. So exactly opposite U5 L4. So L4, what is L4? Where it's L4 now. Okay, it's L4. It's L4. So L5. L5. So L4 is 1 by 2. It's a L5 is I think L5. So just see it. What is L5? 8. 8 means 8 by 24. It's 1 by 3. You will got it's 1 by 3. 1 by 3. So exactly see opposite. It's a negative. it's a compression. It's a tension. It's a positive, it will come negative. Negative. Just join those. Just join those two. Just join those two. Otherwise, you can develop it. No problem at all. Just join those two. Multiply with cosec theta. Multiply with cosec theta. Multiply with cosec theta. It's exactly opposite. Got the idea? Otherwise, you can develop it. You can develop it. U5 L4. You can cut it. You can cut it. Just see. Just to visualize. U5 L4. You cut it. Up to C. Up to load at L1, L2, L3, L4. We will take care of VB. We will take care of VB na? Up to load at L1, L2, L3, L4. We will take care of VB. That's why we write down this VB influence line. See? Up to L4. Up to L4 we will take care of VB. So after L5 we will take care of VA. So that's it. Multiply with cosec theta. That's it. Na? That's it. But it's a changes. Positive, negative will changes because the pattern will change. Now its pattern changes. Na? So previously it will come like this. Now it's come like this. So pattern will come. Just changes. So for you will U6 L6, L5 U6. Can you develop? Same. Up to L5 will take care of VB. Up to L5 will take care of VB. So you can just directly write down. Up to L5 we will take care of VB. L6, L7. That's it. So in between it changes. In between it changes. So what is this value? So otherwise you will see this is C. This is 1 by 6. This is 2 by 3. This is 1 by 6. This is 2 by 3. Cosec theta. It's a power positive. It's negative. That's it. It's a U6 L5. Okay. Where it is? U6 L5. Got the idea? Got the idea? So diagonal members are over. Sir, L1 U2 is remaining, sir. L1 U2 is remaining. So L1 U2 is exceptional. So everything is okay. L1 U2 or U6 L6 is exceptional. So otherwise you want to find out, find out. So L1 U2. L1 U2. Just draw a line. Draw a line. The load at his position is 0. I don't need. So load at position, take care of reaction. No change, no force in the any member. Just avoid it. So load at L2. Load at L2. What is that value? So load at L2, just check it is load at L2. That's it. Na? Load is at L2. So load is at L2. We will consider load at L2. We will consider only right part. See, left part. So no need of left. Right part, left part. Left part, consider it. That's it. Na? So just this is the theta. This theta, it is a VA. It's a VA. Na? It's a VA. Just what is this value? This value it is a U2L1. 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 Sin theta plus VA is plus sin theta VA is 0. So U2L1 is minus of VA cosec theta. That's it. Na? Minus of VA cosec theta. So load at L2. Load at L3. Load at L3 also same. But VA is changing. So load at L4 VA. Load at L5 VA. So so one thing you can understand, the L1 U2 is changing with respect to VA. The changing with respect to VA from L2. From L2 onwards, the change with respect to VA. So that's it. So you can write down L1 U1. From L1 onwards, it's changed with respect to VA. VA is like that? VA like. Sir, before. From L2 to L1, from L to L1 is 0. At L1 is load is there, no members take 0 because the reaction directly will come. Okay, no member will take care. So at L1 is 0, from L2 it's a represent of VA. So and also it's a what is sign? Negative compression sign. Negative compression sign. So, okay. So it's a negative compression sign. It's a 0. Now you can 0 just join it. What is this value? It's a 4. So for 24 it's 1. For 4 1 by 6. This is 1 by 6 cosec theta. Cosec theta is root 2. It is L1 even. It is L1 even. So there is no VB. Everything is with respect to VA. So same thing you can directly write down the U6L7. 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 U6L7 C. U6L7. The load is at cut it section like this. Everything with respect to VB up to load at L1 to L6 with respect to VB. That's it now. We will take care of only right side. So VB, how it is VB is changing. VB is changing. VB is changing. Same diagram. No change at all. So it will come like this. It will come like this. Are understood? So what is the direction, sir? What is the compression or tension? Just check it is. Check it is. It is also same. It is also compression. It is also compression. Are understood? Same. If you see, it is also it's a compression because both are in same direction. It will get negative sign. That is a compression. So this is also compression. This is also compression. Value is same. 1 by 6 cosec theta, that is root 2. This is also compression. So just now, no need to compression find out, tension or how to find out. But just visualize, yeah, visualize. If the load is somewhere here, somewhere here, somewhere here, somewhere here. How the system, how the load is, how the load is compression. Load is compressed. Otherwise, just check it is. If the simply supported beam is load is applied, it will go like this. So top flanges are top layer is going to compress, bottom layer goes to expand it. The same thing you can feel that the bottom charts are expanded, mostly probably in tension. Top chords are in compression. So sides. So if you see just it's a beam, the load is applied. What will happen? It will like. So what is this? These ends are going to be compressed. Ends are going to be compressed. Compressed. So no need to find out. It's both are compressed throughout the load anywhere. So both the edge diagonals are going to be compressed. That's it. That's it. That's why you can develop any member, vertical member, diagonal member, bottom chord, upper chord, any chord. So I developed just one chord and based on that I replica of anything. But someone asked exactly find. So exactly find directly U4, U5. U4, U5. So no need to find out U2, U3 and replica with U4, U5. Just find out U4, U5. That's enough. So cut it, cut the section and take care of movement. So how to choose the point? So any two other loads, any two forces are meeting that point, choose that point as a take care of with respect to movement. That is easy. Previously class we said it. Okay. So any section, any member you can find out. No need to produce. If you want, if someone asks, write down the ILDs for whole 20 members. Whole 20 members. So you have to find out one member and replica with others. No one asks to write down the 20 members. I think we drawn 20 members. I think we drawn ILDs for 20 members. See the diagonal members are we drawn 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Previously I developed 20 members. All members ILDs we drawn it. We drawn it, na? Every member ILD we drawn it. So if someone asks at least 2, 3 members, one diagonal member, one vertical member, one upper chord, one lower chord, 3 members, you can easily develop. You can easily develop. For explaining, it will take hours. Once you know it, directly choose that movement point. So load position is two places: previous position, later position, cutting portion. Okay, that positions are just enough. You can write, right? That's the IL is for trust members. I will give one assignment also. So send a message if you want another lecture on ILDs of trusses. We'll give it another example at Monday. If you no need at all, okay, we will go to the next topic of plastic analysis and from Monday onwards. Okay, I think I give extensionally 2 hours for only one problem. That's enough. Okay, that's enough. I will give assignment. I will give an assignment. So this is a deck type. So that's enough. So friend, very ordinary. The deck type, the load is moving here. So now we have to apply load at these positions, load at that positions, and you get reactions also. You will get reactions. Same thing. So L1, L2, L3, L. Otherwise L mentions is a lower. So now it's upper now. U1, U2, U3, U4, U5, L2, L3, L4. It's everything is 5 meters. 1, 2, 3, 4. 5 into 4 is 20. It's also 5 meters height. It's also 5 meters size. Develop ILDs for U2, U3. One vertical, one upper cord. L3, L4 for one lower cord. U2, U3 one diagonal member, and U2, L2 one vertical member. So this vertical member, this upper cord, UT3 this diagonal member, lower cord is this lower cord. Can you develop it? Try it, develop it. Very simple, no need at all. Just do it. Just do it. Just what we discussed last two classes. That's enough. Okay? That's enough. You can easily develop it just by a method of sections. Cut it, cut it, cut it. Okay? That's enough for the trusses classes. Influence lines for trusses classes. Next class, we will start with plastic analysis, and surveying also we will start with remote sensing. Okay.